without further ado, we're going to be moving on to Arnold Brody in the sky this month. Arnold, take it away.
Thank you, Tom. And hi, everyone, and welcome to the Sky This Month. We'll look at the stargazing highlights from tonight till December the 2nd, the night before our next monthly meeting. And I'll be showing you the night sky as seen from Toronto. As for the highlights, tonight's full moon is a supermoon. Tomorrow evening, the moon visits the Pleiades. This coming Sunday, Pollux, the moon, and Jupiter rise aligned. Monday morning, November 17, is going to be a busy one. It's the peak of the Leonid meteor shower, one of two mornings for the meteor shower peak. And at the same time, a thin crescent moon rises next to Spica. Uranus reaches opposition on the 21st. The following Friday, the modest November Orionids peak. You'll find Saturn rising 4.5 degrees from the moon on the 29th. And on the following night, there's a double occultation of stars in Pisces. In addition, there are 3 comets that you can hopefully find, and all 4 gas and ice giants are up in the night sky this November. Meanwhile, the long nights of mid-autumn offer excellent opportunities to hunt down deep space targets. So this coming month has everything you might want to ask for: planets, comets, meteor showers, deep space, a double occultation, and some close encounters with the moon. And all we really need are some clear skies. I like to combine astronomical twilight, when planets and bright stars can be seen, with night and call it the observing window. In November, the window is almost as wide as it gets, as you see here. And while it's the opposite, of course, for those in the southern hemisphere. Now, for Toronto and similar latitudes, the observing window tonight is almost 12 hours long and over 12 and a half by the beginning of December, when true night is 11 and a half hours long. The moon is full tonight and reaches last quarter a week from tonight. New moon, what I like to call no moon, occurs on Thursday, November 20. Many of the sky scenes I'll be showing you will be during this time period in and around the new moon. Now, the first quarter then is on the 28th, and the full moon goes by a number of names, such as the beaver moon, the deer rutting moon, digging scratching moon, freezing moon, frost moon, the whitefish moon. So let's begin our tour of the night sky with a look at the inner solar system. The inner solar system planets hover near the sun this month, making them hard or impossible to see. Basically, this is not a good month for observing Mercury, Venus, or Mars. Many have single-digit elongations from the sun. After passing inferior conjunction on November 20, Mercury might be possible to catch just before sunrise. Tomorrow morning, Mercury is already a difficult catch, and it's diving down to pass in front of the sun on the 20th. Mars is also diving towards the sun to pass behind it on January 9. It's already unobservable. By December 2, speedy Mercury has reached 19 degrees elongation from the sun and might be observable around 6:30 in the morning, but it'll just be 6.7 degrees up and around magnitude 1 due to air mass, so I don't think it's going to be easy. Here's an overly optimistic suggestion as to how the 42% illuminated Mercury would appear with 480 times magnification, but I don't know. It might be optimistic, too optimistic. Venus is diving behind the sun and is already a difficult catch. Venus is just emerging from behind the sun by early December, but still lost in the sun's glare. We'll need to wait until February for Venus to be noticeable as the evening star. So basically, The inner solar system is a no-show this month, but not so with the outer four. The outer solar system planets all have elongations greater than 90 degrees, so they are on the opposite side of the sky from the sun and inner planets and are visible at some point of the night. Jupiter is west of the sun, so it will rise sometime after sunset. Uranus rises around sunset all month as it passes through opposition on the 21st. Neptune and Saturn appear very close to each other. There are a little over 4 degrees of elongation separating these two planets, so they will appear very close together in the sky. And being east of the sun, they will be well positioned in the western sky for observing as soon as the sky darkens. You'll have no trouble finding Jupiter hanging out with Pollux of the Gemini twins. By mid-month, Jupiter is rising about 5 hours after sunset, shining around magnitude -2 when you factor in our atmosphere. Jupiter enters retrograde motion on November 11. It ends in late March 2026 with the opposition occurring halfway on Jan 10. Now, any size telescope can show you the equatorial belts and the 4 Galilean moons, especially as Jupiter begins to grow in size on its way to opposition. Light blue or light green filters will darken the rusty colored cloud belts and the giant red spot, making them easier to see. Congratulations to Nishat Khan for capturing this outstanding video of a double shadow transit cast by Jupiter's moons, Io and Europa, back on October 4. Claudio Oriani alerted us of this opportunity in his October Sky Talk last month. There is a strong 3D effect as speedier Io overtakes Europa. And you also have the giant red spot rotating into view, so this is an awesome video. Congrats, Nishat. And Nishat and other astro videographers out there, there's another double shadow transit coming up on the night of the no moon, November 20. The double transits will already be underway as Jupiter rises into the night sky. So good luck. Maybe we'll see another video posted. You can find Uranus 4 degrees southeast of the Pleiades. And here we see it on the night before its opposition when the moon is new. Being brighter than magnitude 6, people with good vision should be able to spot it on a moonless night if you're far from light pollution. Start the challenge by finding Uranus in binoculars. You'll know when you find it. It's obviously blue and has a disc shape, not like a scintillating star point. By magically erasing all stars dimmer than magnitude 6, we're left with 3 with magnitudes similar to Uranus. Now, keep your head and gaze stationary and slowly lower the binoculars and find these 3 stars. The bottom left star might be too dim to see, but if you can see the other 3 dots, the one in the middle is Uranus, and that would be this one right here. Saturn and Neptune can be found near each other in the southwest after nightfall. Saturn's magnitude 0.87 butterscotch dot is 6 degrees below the circlet in Pisces. And as we saw earlier, Neptune is found around 4 degrees east of Saturn. Saturn's retrograde motion, which began in mid-July, will end on November 27. Saturn will then start drifting westward against the background stars. And we can still catch Saturn due south as it crosses the meridian around 8 p.m. Both planets will set around 2 in the morning. Saturn's rings have narrowed again since the ring plane crossing back in March. The tilt had grown to 3.5 degrees back in the summer, but has narrowed again since, down to a slender 1/3 of a degree, making the rings very hard to see, while making its moons easier. The narrow rings make Saturn's dot in the sky dim, since the rings are reflecting back virtually no light. when they're nicely tilted, they can reflect back as much light as the planet itself, making the dot in the sky appear that much brighter. Right now, it's kind of dim, but you can still find it. Now, it says here that you can use a light yellow filter to improve contrast in Saturn's rings, but right now we can't see the rings, let alone improve contrast in them. But maybe a greenish filter will help with the cloud bands, make them stand out a little bit. With your telescope aimed at Saturn, you can find Neptune by slewing 3.4 degrees east and 2.6 degrees north. And you'll know when you find it when you spot a blue dot halfway on a line connecting three stars of similar or less brightness. The line makes a stubby off-center T with a fourth star. So if you can find that arrangement of stars, then you'll know that Neptune is this blue dot here, halfway along this long line, and it's going to be obviously blue, and you should be able to see its tiny disk shape as well. As for the comets, there are two in the west and north that should be within reach of backyard telescopes this month. Unlike the typical scenario of comets hugging the horizon near the sun, Comet C 2025R2 Swan will be found hovering in the west, while C 2025K1 Atlas slices through the circumpolar region. Comet C 2025R2 Swan is a long-period comet discovered on the 11th of September 2025 by amateur astronomer Vladimir Bezugli, who was studying imagery that was captured by the SWAN instrument, which is in space on board the SOHO spacecraft. The comet reached perigee just a couple of weeks ago on October 20 and is now receding away from us, as you can see with the spacing of its daily movement in the sky. The wider spacing you see early here, these are dates in November, 13, 14. They become tighter and tighter and tighter and closer as SWAN recedes away from us. The comet's light curve shows it peaking at perigee and dropping off quickly since. It should be visible in binoculars now, but I'm not sure for how long. Its light curve is dropping quickly, and it should, however, still be a relatively easy target in telescopes. The most common gases detected in the comet's coma include diatomic carbon, amino radical, and atomic oxygen. Comet C 2025K1 Atlas is visible now. For the first 3 weeks of November, you'll need to be out a few hours before sunrise to observe the comet as it heads northward through the zodiac. But by the 21st, Atlas will enter the circumpolar region, and you'll be able to observe it after dinner instead of before breakfast. The comet is predicted to hover around 11th magnitude, requiring a telescope to see. The comet came from the Oort cloud, which is a sphere 2,000 to 200,000 astronomical units from the sun. So comets that are dislodged from that spherical cloud won't have a bias for the ecliptic plane, and they can travel at steep angles to the ecliptic and pass over the polar region like this one. The comet came within a third of an AU of the sun, almost as close as Mercury, and beat expectations many had that it wouldn't survive the encounter, but it did, re-emerging on October 18. Spectroscopic analysis of the comet's coma show it to be depleted in carbon, cyanogen compounds, and has low dust-to-gas ratio, and those are characteristics observed twice before from Oort cloud comets, and are likely the result of not receiving much radiation from our sun for billions of years, for virtually their entire lifetimes. Closest approach to Earth will be on Tuesday, the 25th of November, 2025, at a distance of 60.3 million kilometers, or 0.4 AU, 0.4. Now, notice how much the comet travels per night during this perigee. And here are the dates again. Here's the 25th, 26th, and so on. And you can see that there's quite a gap between each dot for each day, for each night. So it is moving across the region quite quickly. C2025K1 is traveling at 50 kilometers a second relative to the sun on a hyperbolic orbit. And that means it will escape our solar system. November and December present your best prospects for seeing the headlines-grabbing comet 3I Atlas as it reemerges from behind the sun low in the dawn. The interstellar visitor brightened unexpectedly to 11th degree magnitude as it passed perihelion just days ago on October 29. If it remains that bright, it will be visible in backyard telescopes as it moves through Virgo and Leo, as it climbs even higher into the pre-dawn sky. Now, how long it remains bright enough to see in telescopes is questionable, because the comet is rushing out at 200,000 kilometers an hour, or 61 kilometers a second. With an eccentricity of 6, its path had very little bend as it cruised past the sun. In early 2026, the comet will enter Gemini and exit the solar system in the direction of the star Zeta Geminorum, resuming its long journey through deep interstellar space. The comet is rich in carbon dioxide and contains a small amount of water ice, water vapor, carbon monoxide, carbonyl sulfide, cyanide gas, and atomic nickel vapor at concentrations similar to those seen in solar system comets. Now, many of the headlines were over speculation the comet had non-natural alien origins, thanks to an article by Harvard University science professor Avi Loeb, who brought up the suggestion. Meanwhile, a chorus of professional astronomers disagree, saying it looks like a comet and is behaving like a comet. And if you could get close enough, it probably tastes like a comet. In fact, 2 European Space Agency spacecraft have. The Hera craft passed through the ion tail between October 25 and November 1st. And their Europa Clipper is doing the same from October 30 to tomorrow, November 6. These were unplanned but scientifically fortunate opportunities, and it will be interesting to learn what they detect. November is a busy month for meteor showers, starting with the south and north Taurids, 2 meteoroid streams deposited by 2P NP. The South Taurids peak tonight, but with the biggest, baddest full moon of the year tonight, most of those meteors will be washed out. But maybe we can catch a few later since we remain in the meteor stream the rest of the month and into December. The North Taurids peak a week tonight when the moon is third quarter rising at midnight. And because the radiance of these showers rise early in the evening, you don't need to wait until late at night to see them. The 2 Taurids are among the slowest of meteors and can produce fireballs. 1 week later again, on the morning of November 17, as well as the morning of the 18th, the dependable Leonid meteor shower is peaking, producing around 15 meteors an hour. In Toronto and at similar latitudes, we can hope for 9 an hour, and that's a good number. The moon will be nearly new, staying out of the way until nearly sunrise, so that's great. The debris stream left from 55P Temple Tuttle slam into our atmosphere at a fierce 70 kilometers a second, and that can produce very bright meteors. The North Orionids is the last meteor shower to peak this month, which is on November 28. By midnight, when the shower's radiant is high in the south, the first quarter moon will be setting. This is a minor shower with a ZHR of only 3. If you're stargazing on or around the 28th and spot a meteor, trace its path backwards to see if it takes you to Orion. The much anticipated Geminids with a generous zenith hourly rate of 150, arrive on November 19 and remain active up to December 24th. Now, the peak won't happen until mid-December when the moon does not rise until 2:30. Bright, colorful meteors may streak across your sky in the second half of November. This shower is unusual in that the debris was left behind by asteroid, not comet, but asteroid 3200 Phaethon, whose orbit crosses Earth's and is considered a potential threat. Phaethon is not an icy body. Its water has combined with other molecules to form phyllosilicate and carbonate materials. When heated to 800 degrees Celsius by the sun, these carbonates release carbon dioxide gas, while the phyllosilicate give off water vapor, and sulfides in the asteroid release sulfur gas. And these gases exert pressure on rocky material, producing small cracks and small pieces and dust particles that the gases lift off from the asteroid. As for the sun at local noon drops by 6.16 degrees over the next 4 weeks, while Earth nears its perihelion in early January. Earth's orbital speed is increasing as we head towards perihelion, while our rate of rotation is constant, and this causes the sun's position at 12 p.m. to drift eastward each day on its way to forming the analemma. The sun is still active. Solar cycle 25 may have peaked earlier this year, but eruptions and CMEs have been detected on the far side of the sun. Coronal holes have also developed, allowing the solar wind to come racing out, producing auroras here. These holes are also linked to the unstable magnetic fields. There is a correlation. These videos were produced by the LASCO C3 camera also on board the SOHO spacecraft. It shows massive ejections released on the far side of the sun from active regions, such as 4246 that were previously Earth-facing, but still going strong. Now, will these regions still have bullets or be shooting blanks by the time they face us again, which is beginning now? So keep monitoring your favorite aurora forecast sites because we might have some activity the first week or so of November. The moon tonight coincides with perigee, making this a supermoon, the second and closest of 4 consecutive supermoons that occur in a series. This is generating significant king tides along coastlines. The last quarter moon is a week from tonight on the 12th. When the moon reaches new on the 20th, it also reaches apogee, making this a micromoon and the smallest micromoon of the year as well. First quarter is on November the 28th. And on December the 2nd, the moon is just days away from being a supermoon again. One of the month's highlights mentioned at the start is a double occultation on November 30, when the moon passes in front of 62 and Delta Piscium just 34 minutes apart. 25 Piscium is probably too dim to see naked eye, but Delta at magnitude 4.4 should be visible from a fairly dark site. That star is a red giant that has drifted off the main sequence. Delta Piscium is a double star, but its companion at magnitude 14 is too dim to be seen in amateur telescopes. Now, for us in Toronto, the first occultation is 5 seconds before 8:20. And then the cult's Delta Piscium. Now, after the occultations are over, keep your telescope focused on the moon. There's an interesting crater catching sunrise and is prime for exploration. It's crater Gassendi, one of the targets in the Explore the Moon observing program. Gassendi is a 111-kilometer circular crater with unusually low walls. That's because the crater was flooded by lava when a monster asteroid collided and formed Mare Humorum. The lava breached almost to the peaks of the central mountains in the crater center that are now just protruding above the surface. The crater's rim is heavily worn but still circular. It varies in height from just 200 meters at the south end to 2.5 kilometers high on the east wall, casting that nice shadow we see here. Gassendi A is the 20 or so kilometer wide crater that sits right on the Gassendi's northern rim, making the pair look like a diamond ring. And if seeing conditions are really good for you, see if you can detect this semicircular ring pattern here paralleling the southern wall, and notice how the land lifts up here. There's a rampart here up to this north rim supporting the diamond. Now, besides the double occultation just mentioned, there are 4 close encounters involving the moon this month. Tomorrow evening, you can watch the moon and the Pleiades rise just 6 degrees apart. And if you wait for the Hyades and brilliant Aldebaran to rise, by 7:30 p.m., you'll have a glittering scene worth photographing, if you can include an interesting foreground. This coming Sunday evening, Pollux, the moon, and Jupiter rise aligned. The crooked line becomes a straight line in a few hours as the moon drifts eastward between Pollux and Jupiter. While out enjoying the Leonid meteor shower, you can watch the moon rise very close to Spica. Maybe a meteor will shoot past the pair. And as the sky darkens outside the DDO on Saturday, November the 29th, you'll find Saturn rising just 4.5 degrees from the moon. Now, because of the long observing window mentioned at the start, we can see the constellations and stars from all 4 seasons. Here's the view to the south mid-month at the start of night. You can still catch Messiers and other deep space targets in the southern Milky Way, in the summer Milky Way. And in the south and southeast, the parade of the fall constellations is led by Capricornus, Aquarius, and Pegasus. The great Andromeda Galaxy approaches a zenith. Saturn and Neptune are found below Pisces. And by 11 p.m., the winter constellations rise into view. And if you stay up all night or decide to get up before sunrise, you'll see the spring constellations fill the eastern half of the sky. So you can see the constellations and stars from all 4 seasons. The only stars we cannot see are those in Scorpius and Libra. So that got me to thinking, if that much sky is visible this month, how many of the Messiers could one observe? To find out, I visited the Calgary Center's website and used this Messier Marathon Planner written by Larry McNish. I selected November 18, when the moon is nearly new and not sitting in the middle of the Virgo cluster. I chose Toronto as the site. I said objects had to be at least 10 degrees above the horizon. The sun had to be 18 degrees down, in other words, night. And as a result of these parameters, the not possible count came back at 12. In other words, 98 or 89% of the Messiers are. Now, a number of those Messiers pass very close to the zenith on November the 18th, giving us an opportunity to view or image them through the least amount of atmosphere possible. And here are some examples. At the start of night, around 6:30 p.m., open cluster Messier 39 can be found 9 degrees east of Deneb in Cygnus. At a distance of 825 light years, it's quite bright at 4.6 and can be detected by eyes alone as a faint hazy patch under a dark no-moon sky. It's an easy binocular target and best seen in the telescope under low power since it covers a half a degree of sky like our moon. Its Trumpler classification is III2P, meaning the cluster is not concentrated towards the center. It has a small range of brightness amongst its stars, and the number of stars is poor, meaning up to 50. So here's a view showing the stars. They are quite the same in brightness. There's a few that are a little bit dimmer, and there's about 50 of them. 50 or under 50 is considered poor, the letter P. On the 18th, the trio of galaxies M31, M32, and M110 come within 5 degrees of your zenith around 2048. This close to the zenith, you're peering through the least amount of atmosphere possible. It's an excellent opportunity to observe or photograph the trio. M31, the Andromeda Galaxy, is a barred spiral monster with up to 1 trillion stars. M32 is a rare, compact elliptical. Ellipticals tend to be the result of larger galaxies merging, and M110 is a more typical dwarf elliptical, more typical. Now, Charles Messier discovered Messier M110 back in 1733, according to the observing notes that he left behind, but for whatever reason, he chose not to include it in his list of fuzzy things that aren't comets. Instead, it was added posthumously in 1966. Messier's 104 and up were added to the catalog in the 1900s. Meanwhile, M32 and M110 are the brightest of 37 small galaxies, small satellite galaxies that orbit the Andromeda Galaxy. Astronomers at the Leibniz Institute for Astrophysics, Potsdam, have determined that 80% of the satellite galaxies lie in one hemisphere on the Milky Way side of Andromeda. Well, that's food for thought as you study this trio in binoculars. In this simulation from Stellarium, I set the atmosphere light pollution index to Bortle 5, hoping to mimic the sky over the Carr Astronomical Observatory. Now, if you are imaging these galaxies, take 2 hours of exposures, because that's when M37 comes to about a degree of your zenith. It's been coined the spiral galaxy, the spiral cluster, by Jeff Bondo, from what he perceived to be a spiral of stars in its makeup. Now, you can easily find the cluster in binoculars by scanning 1 degree above and slightly to the left of the halfway point between Algol and Almach. M34 is 1,400 light years away and estimated to be 200 to 250 million years old. It's over half a degree wide, and in telescopes, it's best observed under low power. And under a transparent dark sky, again, it can be detected by eye alone. Up to 80 of its estimated 100 stars can be resolved in a telescope. It's considered to be somewhat concentrated with a wide brightness range among its 100 stars. There's actually a recording that was made back on Monday. We wanted to avoid any internet interruptions that might occur. So I thank Andrew for recording this ahead of time. And what I'd like to show you now is this terrific eruption that occurred. I was mentioning in the video that the active regions that are now rotating into view, would they have bullets or would they be shooting blanks, I was asking. Well, they were definitely shooting real bullets. This is a class X1 flare. Let's see here. X1.8. Yes. Very strong flare. Now, this one's missing us, apparently, because it's not Earth facing. However, it's going to continue to rotate towards us. So, as I was supposing in the talk, you keep an eye on your favorite aurora forecast sites. We do have very high levels being predicted sometime during this coming week. So, definitely, we're in for another round potentially of some sunspot, some auroras overhead. So now then, I'm more than happy to, well, first of all, thank everybody for watching the show. And I'd like to ask if there are any questions.
Thank you very much, Arnold. That was a wonderful presentation. And yes, Betty, do we have any questions for Arnold from the chat?
Not tonight.
No questions?
But I love the hologram in the background. And you had amazing graphics.
Yeah, thank you. It's fun putting it together.